All right, let's do it. So I'm Pat Hu. I'm with the Bureau of Transportation Statistics. I'll be moderating this section on analyzing both people and freight movements with waypoint and trip data. As you can see, we have one presentation dropped out, so we're going to try to give some time back to you, hopefully. So what I would do is I would introduce each of the presenter, and each one of them has 20 minutes, and then perhaps we can use some time after the presentation to ask for a Q&A. If we have time left after the three presentations, we can open up the floor for more Q&As if we want, okay? So our first presenter is Avital Vainberg. She's a third-year undergraduate student at Urban Science and Planning at MIT. She's very interested in integrating and applying big data to planning implications of cutting-edge mobility innovations. Her work focuses on modeling, visualizing, and analyzing patterns of daily activities using travel survey data. So her presentation will be on the visualizing spatial-temporal activity travel patterns. And with that,
okay. Hi, I'm Avital. Thank you so much for having me here. This is a really great privilege, especially as an undergraduate student. As Pat mentioned, I am an undergrad at MIT, and I'm working with Ronak Basu and Professor Joseph Ferreira on this project with the Future Urban Mobility Lab under the Singapore-MIT Alliance for Transport Research and Technology. So my project is visualizing spatio-temporal activity travel patterns in Singapore. So obviously the question we're all asking are where, when, and why are people traveling? We want to know this in planning, in policy, in industry, and so the main focus of most of the research these days are kind of looking at daily travel patterns, which then kind of goes into traffic simulations, and then we get from that network congestion visualization. My project, on the other hand, does not really want to look at network congestion. We want to compare that to activity patterns, so where people actually want to go as opposed to where they're being stuck in traffic. So we use traditional travel survey data to show these daily activity patterns, and we visualize the straight line distance and direction of travel to observe the spatio-temporal variation across multiple years. So basically, we want to take something like this, which is a static image of people in Singapore. So every dot is a person, and every color is basically the activity that they're doing at that moment, or if they're traveling, the activity that they're traveling to. But we want to animate this in order to see the changes throughout time. So the data that we used was the household interview travel survey data called HITS from the Singapore Land Transport Authority in 2008 and 2012. And this was a 1% sample of citizens and permanent residents in Singapore with around 10,000 households, 35,000 residents, and 75,000 trips. So just a little overview of the data, percentage of trips by activity. This kind of makes sense. So we see that around 50% of the trips were home, which, you know, if people are going somewhere, they're usually going to go home after. And then most of the people are going to work or school, and then there's some personal activities as well. So we're going to kind of track these throughout both data sets and throughout the 24-hour time lapse. So I started by taking the HITS data and separating it into trips, people, and households. This was just to clean the data and make sure that we're efficiently processing it later. The people and household data kind of covers socio-demographic information about the households and the people, car and home ownership, and other kind of useful information on that end. And then the trips data, which is what I concentrate most on in this project, has the person ID, which we can then cross-reference with the person, with the people information later, start postcode for each trip, an end postcode, a start time, an end time, and the next activity, or the current activity if they're not moving, and then sampling weights. So as you can see, so person 1 here has sampling weight of 110, which means in the visualization, the dot is going to be a lot bigger than the person 2, which only has a sampling weight of 50. So then once I have this trips, every trip in the data, I then processed the straight line interpolation. So I wanted to get each person's location at every minute using just a straight line interpolation as opposed to using the current traffic network. So then I ended up with the location of every individual for every minute. So there was a file for every minute, that's 1440 files, and then there was an entry for each person with their X, Y location and the activity that they're either doing at the time or that they're traveling to. And then each one of those files ended up generating an image with kind of like the one you saw before, with the location of each person, and the color of that person is the activity that they're doing, and then I stitched all those images together to create a video. And in order to more efficiently and quickly process the data, because it could get kind of big depending on the city that we're working with, we could, parallelized it using multiple threads. Here I kind of show it with 2 threads. We use 7. It really depends on the computer that you're using, but that's just kind of a way to make it faster and more efficient. So here we have our first video, and as you can see, people are at home at 4 a.m. Between 5 to 6 a.m., you see people are going to school, and that's kind of regionalized within where people live. But then they go to work, and it's more centralized in the downtown and then western areas of the city where there's more industry. At 12, you can see some activity for lunch, and then you can also, and then starting at 5 p.m., you'll see that people start to leave, but as opposed to having it's more varied peak as opposed to in the morning, because instead of going straight home, they're also doing personal activities, they're going to eat dinner with their families, they're going shopping. So here you can see that it's very informative seeing where people are living, where people are going to school, where people are working, and not just looking at where they're getting stuck in traffic. And so here you can compare 2008 to 2012. We can see that Singapore they were trying to decentralize both residential and work and shopping locations. So between 2008 and 2012. So we can see more varied colors outside of the downtown areas because there are more shopping centers. You could see that there's more residential areas and throughout the city. But one limitation that we do have is we can't see different changes in transportation infrastructure. So between 2008 and 2012, the Circle Line was built in the downtown area, and so that's something that we can't really see in this comparison. So because of that, we really need to compare these visualizations to traffic simulations, which is the next stage. So in this video here, you can see the morning peaks. This is between 7 a.m. and 10:30 a.m., comparing the visualization that I created with a traffic simulation from the same lab that I work in. It's called SimMobility. And here you can kind of start seeing which activities are causing congestion at different times of the day. So up in the northern part of the city, you can see that in the morning, the congestion increases because of students going to school. And then an hour later, there's congestion more towards the downtown area because people are going to work. And then that congestion kind of decreases once people are at work or at school. So yeah, so in conclusion, so we created these activity pattern visualizations using these traditional survey data to show human mobility patterns and show why people are going places and what they want to do. And then once we have this, we can compare this with traffic simulations and understand, the relationship between land use and transportation infrastructure, what people are doing and where they want to go. And then also the process uses very accessible travel survey data that is done across multiple cities and is pretty generalizable and parallelizable, so it can be processed pretty efficiently throughout different cities, not just Singapore. Yeah, that is all. So thank you. If anyone has any questions. Yeah. I use Python, so I just use matplotlib. Yeah, mostly that, like pandas. Yeah. Yeah, so the travel survey data is actually collected by humans and is inputted by humans. So usually when someone asks you when you left the house, they're going to say, 7 a.m. or 7:15 a.m. or something like that. So you'll see probably on those round times that there's a pop of color because that's when people are starting to move. That's just a representation of what people say in these travel survey datas. Yeah. Yeah. Sorry.
So, as far as I remember, when you saw the snapshot of your trip data, the trip ends were not GPS, were just zip codes, is that right?
Yeah.
So, did you use the zip codes Troy for priority cards destination, just to randomize the trip ends so that they fall inside the zip code location?
Yeah, so for your first question, we're actually in the beginning process of this project. This is what we have right now. Next stages include like making a dashboard, a website where we can see more of the data. So basing it off of demographics of the house, mode of transportation, and then also using some more statistical analyses to get actual numeric information out of it. So right now we don't have anything from that, but we will. And then in terms of the postcode, so in Singapore, a postcode is actually very, very specific. It's like by house almost. So there's a very specific XY coordinate for each postcode. Yeah.
Hi, did you say you used Matplotlib?
Matplotlib, yeah.
There's a nice color map in there called VIZ19. If ever you need to use it.
Okay, thank you.
Any other? Is this on? Well, any other questions?
Can you just go back to your slide showing the traffic purpose, the composition of your traffic purpose?
I don't know how to go back on this. Oh, am I getting it? Okay. Which one?
The slide is showing the proportion of the traffic activities by traffic purpose. I think like shopping and home and work. Yeah, this one.
Yeah, okay.
So my question is, from your data, it seems from 2009, 2008 to 2012, the shopping share is increasing, right? From
Yeah.
3% to 4%. So
Okay.
my question is, okay, we're also using the national household travel survey data of the United States. So I also analyzed the travel purpose of the Americans. So I found that in the past 10 years, actually the shopping shares of the traffic activities is very sharp, very clearly decreases in the United States. So probably it's because of the popularity of the online shopping now. So my question is, do you know why is in Singapore, in your time period, the shopping share is so increasing trend?
I'm just reflecting the data here. I have not looked into the reasons behind it yet. So I don't know, I guess.